Welcome to Pure One, Chapter 9.4, which in here we are talking about some problem-solving question about triangle using sine rule, cosine rule, and different sort of, everything knowledge about, about triangles. Here's just a little quote from the legend from Bruce Lee about be water, my friend. The reason because is in problem solving, and one thing that a lot of students hate in maths about problem solving is because there's no one rule fits all. And that's why but that's the beauty of the maths. Every question is slightly different. If you want to do something exactly the same, go learn history. Learn in the past, live in the past. But here we do maths. We do problem solving questions. Right. So notes to help you alleviate some of the struggle you have with problem solving questions. So you might want to consider the following. Um, basic trick, SOHCAHTOA. Think about Pythagoras. These are something useful you can think about. Sine rule, cosine rule, sine, cosine rule, and also maybe half AB sine C. These are useful things to think about when it comes to triangles. All right. So in here, example, if you want to think about work out the value of x in here. Now we've got three lengths and an angle. So cosine rule. Yeah, cosine rule. So the angle 30-degree opposite to it has to be A. So this has to be A, this will B, and this will be C. So cosine rule, A squared equals B squared plus C squared minus 2BC cos A. By the way, if you know how to do this, you can pause video and have a go at the both question and you can check your answer with me. A squared will be 3 squared equals 4 squared plus x squared minus 2 times 4 times C, which is x, times cos 32 degree. Step by step, one by one, 3 squared is 9, 4 squared is 16. Subtract over will be -7 equals x squared minus 2 times 4 is 8. 8x cos 32 degree. Okay, right. Then what we're doing here is there are different ways. What we can do in here is potentially we can put in a calculator because it's a quadratic. You can see it's a quadratic because there's x squared, there's x in there. So I'll bring a -7 to the right hand side, becomes a plus. So x squared minus 8x cos 32 plus 7. So how do we solve this quadratic? Looks like a weird one. Well, we've got our mighty calculator, haven't we? So we can use a calculator to solve the quadratic. If you don't have the A-level calculator, if you only have a GCSE one, essentially what we're doing here is the value of A is 1, the B is -8 cos 32, and the value of C is 7. You can use the quadratic formula yourself. Let me bring up a calculator. So again, you can go on the calculator, go on menu, and then press A function and equation. Go with that tab, and then polynomial degrees 2, press 1, and then the x value, the b value will be -8 cos 32. One thing to know, make sure your calculator is in degrees mode, signified by a D on the top. If you don't have the degrees, you can press shift menu, and then press shift menu to change the angle unit. You should press 1 for degree. Okay, so let's try it. -8 cos 32, and then y will be 7. Just let the calculator solve it. You get 5.52, and that's the answer. So x equals 5.52. Okay, you don't have to show any steps in between them. Okay, is there an alternative way of doing it? Yes, of course. You can use sine rule to work out this angle, to work out the other, to work out this angle, and then work out that angle using angles in triangle, and then do it the other way around. But you should get 5.52. Hey, for this one, pause video, have a go at the question. When you're ready for the answer, you can press play. Here's the final answer. Y should be 6.97. I've shown you the full working out. So your A should be 9. So 9 squared equals B. I make it to be Y. You can make it be 10. Remember, the B and C value does not matter which one is which way around. So Y squared plus 10 squared equals -2 times Y times 10 cos 61. Simplify the algebra. Simplify into quadratic. You should see B is -20 cos 61. Put it in a calculator. Don't forget a minus. You get 6.97. Right? Yes. Right. Example. Okay. Or practice question 2. If you feel like you want to have a go with this question first, be my guest. Be water, my friend. Pause video, have a go if you want to. Okay. Otherwise, let me give you the answer. The final answer would be oh, okay, let me pause video and write the answer. Well, here are the final answers for question A, B, and C. Okay, if you do as a practice. But let's have a go on this one. Okay, so the diagram shows the location of four mobile phone masts in the field. The masts, if you don't know what they are, basically they are the signal towers, so that how your phone always have signal because they are always within every coverage by the mast. So anyone in between the masts always have a signal coverage by your phone company. In the field. BC equals 75, so these are all shown in diagram. Okay, so in order that the masts do not interfere with each other, they must be at least 70 meters apart. Given that A is the minimum distance from D, okay, so 70, find the distance A is from B. Essentially, I want you to find AB. Okay, so in here, you see a quadrilateral. First thing I will think about is in a quadrilateral, unless it's a square rectangle or something a bit more recognizable, these shapes are not usually helpful to work out any values. So what I would do is probably cut into half, two triangles, this way probably. Now, what about, sir, can you cut in the other way? Like this way. Yes, you can. If you have done it that way, it will work as well. It's just the same way. But in just my notes, I cut in that way. Both ways, I verified myself works. Okay. Right. So I'm going to cut in this way. So if I want to work out AB, okay, think about it. If you want to work out AB, that's final answer X centimeter. Now let's look at triangle ABD. It's quite bland. We only got 70 meters and X centimeter. X centimeter, we don't use centimeter in here, child. We use meter. Um, and even though we have a degree in here, but we don't have any degree inside the triangle ABD, it's not 70 degree. We don't know if it's 70. Actually, it shouldn't be 70 because they're not, what's the word, congruent. They're not symmetrical. They're not identical. So we don't know if that's 70. Okay, if it's 70, 70, but we can't tell. We can't be sure. So what we need to do is we need to use this triangle BCD to help us to work out more information for us to use for ABD. Well, one line that it shares is BD. So I think work out BD will be quite useful, right? So we look at the BCD triangle. So I'm going to draw the BCD triangle in here just very quickly. So BCD triangle. Yeah, that's the BCD triangle. 75, and then there's 80, and that's 45 degree. Okay, if I want to work out BD, I can use cosine rule again, right? So cosine rule. So if I want to work out BD, so BD squared equals, now if you remember what I said last time, sometimes it's useful for you to write down the formula first, the cosine rule, so you don't have to recall as you do the maths. So you've done the recording process, now it's just the substitution process. BD squared equals BC 75 squared plus 80 squared minus 2 times 75 times 80 cos A, which is 55 degree. I'll put the whole thing in the calculator and then square root that. You should get, put in the calculator, you should get 71.7 meters. Okay, so that's 71.7. So something now we now know BD 71.7. Useful, but is that enough? No, because if you want to use sine rule or cosine rule, you need at least one angle. To work out one angle, well, I think one useful thing or one information we have not used is 140 degree. So perhaps if we can work out this little angle in here, then we can work out the other angle because they both add up to 140 degree. So next task is to work out alpha. I'm going to call this alpha. Okay, I'm going to call this alpha. Okay, so to work out alpha, you can either use sine rule or cosine rule. I think sine rule will be the easier one because sine rule usually has less calculation. Okay, so to work out alpha, so I will do sine alpha over 75, okay, equals, so sine A over A equal sine B over B. So sine 55 degree over the BD, which is 71.7. So alpha equals inverse sine of, so sine 55 over 71.7 times 75. Well, where did it come from, sir? Times 75 over the right-hand side, and then inverse sine or arc sine. Okay, put in the calculator, you should get 59 degree. So 59 degree. Okay, so therefore, we know now the angle ADB, which is the one that we need. So ADB is the one here, equals to 140 degree minus 59 degree, which is 81 degree. So if I want to work out the length of AB, now let me draw a triangle ABD out. So AB, D like that, right? Yep. So ABD, I know AB is X. I know this angle here is 81 degree. I know this is 70 meters, and I know this is 71.7 meters. So three lengths, and an angle, cosine rule. So cosine rule. here to here. Well, I know that's the cosine rules. That's the A, B, and C. So useful. So A squared, so X squared equals B squared plus C squared minus 2 times B times C cos 81. So X equals square root the whole thing. Put in the calculator. You should get 92 meters. Okay, if you're unsure, plug in the calculator. Trust me. Actually, I can't trust myself. Let me put in the calculator once. So square root of 70 squared plus 71.7 squared minus 2 times 70 times 71.7 cos 81. Yes, 92 meters, right? So that's the answer for question A. B, the angle BAD. So where's the angle BAD? The angle BAD is here. So let's call this, I don't know, let's call this theta. Okay, so we'll work out angle BAD. So we can use the triangle BAD, so we'll work out theta. So in part B, let's do that. Question B, to work out angle theta, perhaps we can use sine rule. Okay, you should, because two angles, sine rule. So sine theta over 1.7 equal sine 81 over x, which is 92. So therefore, if I multiply 71.7 over first, so sine 81 over 92 times 71.7, and then I will do inverse of that. Let me rewrite that. Or inside a bracket. So put in a calculator, inverse sine of fraction, sine 81. Make sure you put in a calculator carefully. Times 71.7. You should get 50.3 degree. And another answer. Okay. Part C, find the area enclosed by the four masses. To find the area, you can see there are two triangles. So we want to work up one by one. So the area of one triangle times the area of the other triangle. So the area of angle BAD, now we don't use half base times height. We don't use half base times height because if we use the height, you must have a right angle triangle or a perpendicular height, which you can find it if you want to go out of the way, if you want to go extra mile unnecessarily. But in here, you could use half AB sine C and the half AB sine C. So the angle, so the triangle BAD. So let me do it here actually. So part C. Okay, so part C. So the area, so total area equals the area of BAD plus triangle of BCD. So that one is half x, which is 92, if my memory serves me correctly, times 70 sine theta. What's theta again? 50.3. Right, so equals, so half, yep, 81. Oh, hang on, it's theta. Hang on, theta. What's theta again? Let me double check. Theta is 50.3 degree. It's theta 50.3 degree. Yep, theta. Okay, so put in a calculator. So 0.5 times 92 times 70 sine 50.3. I get 2477.47. Okay, next one. Angle, triangle BCD, half AB sine C. So 70, 80, and 55. So half 75 times 80 times sine 55. Put in a calculator, 0.5 times 75 times 80 sine 55. 2457.46. Therefore, the total area equals to 2477.47 plus 2457.46. Then the calculator, and I got 4934.9, which is 4935 meters squared. Now, might be wondering, why is my answer incorrect, different to the one I put on the question, the beginning? That's because of rounding error. I did not use the full value when I used this angle 59 degrees, so that when I do 140 minus 59, that gives me 81. This value is not exact. Now imagine I used the not exact value in a further calculation that gives me more rounding error going on and on and on. All right, these values are all incorrect. So not incorrect in that sense, it's just marginally incorrect. So how do we fix this? Well, to fix this, you can actually use a calculator. button, which is called store value. I'm going to show you in here as well if you're interested. So give me a second. For example, in here, let's say I want to use the full value of 59 degrees. So what I can do is let me put this inverse sign. Okay, so inverse sign, oops, inverse sign of fraction sine 55 over say 1.7 times 75. Okay, so I got this 58.96 degree. If I want to use the full value, I can use the store. Can you see this STO button here? Once I press STO, then I can choose these A, B, C, D, E, F, X, Y, and M. These are memory boxes. You can store them. So if I want to store in A, I can just press this button here, minus. You can see a calculator automatically gives answer to A. Now, some of the more advanced calculator, you will have to type it out by yourself. If you don't see the store button in the calculator, you can just press answer. And then, so next line is answer. And then your calculator should have an arrow button like this one. And then type it out manually, answer to A, and then execute. But if you have more doubt, ask your teacher about how to store value in calculator or do some Google yourself. So now I've stored in A. That means if I want to use this A value in the further calculation, use a 59 degree, I can replace it with A. For example, if I want to work out sine 59 degree, so I'll do sine, instead of 59, I'll put sine A instead. Okay. If I want to use 58.59 degree, let's say half AB sine C. So half, I don't know, just make it up, times half AB sine. So whenever I want to use the value, I'll use A instead. Okay. Right. So that's how we use the memory boxes. Okay. Right. Yeah. Okay. Practice question 3. Pause the video. Have a go at the question. Is that the final one? Yep, that's the final one. Whenever you finish, whenever you're done, you can play the video. So the final answer is 107 kilometers. Okay. If you got it right, well, good job. That's the end of lesson for you. Okay. But if you don't, let's have a look. So helicopters flies on the bearing. We mentioned about bearing last lesson already, which is from a north line, counted clockwise, from A to B. So of 120 degree from A to B. So I might, okay, so from A, so let me draw A. I don't know where B. So A is here. So definitely north line. 200 degree means that's 90, 180, 200 somewhere here. That's B. Okay, so and I know this is actually the A is in an inconvenient position in here. Let me put it A in here. So that's 200 degree. Okay, where AB is 70 kilometers, 70 kilometers. It then flies on the bearing of 150 degree from B to C. That means the bearings measure now from B. So I'm going to draw a north line from B. Okay, the north line, 150 degree. So I know that's 90. So 150 is somewhere here. That's C, and that's 150 degree. Okay, where C is due south of A. Oh, due south, that means I need to make this line a bit longer because C is directly, oh, actually, okay. So, because C is directly underneath A, it's due south, that means it's directly underneath A. Okay, right, so I know, and I know that's what, I don't know anything else. So I know that's 180 degree. Work out distance of C from A. So I'm going to work out this X value, X kilometers. So I'll probably put 70 degree outside, 70 kilometers outside. Now, one thing about bearing is if you haven't learned, if you don't remember from GCSE, is that you can actually use the properties of parallel lines, the angles. So for example, in here, to work up, so I know quite a lot of things in here because if I know that's 200, by the way, first thing first, this must be 160 degree, right? If that's 160 degree, because the two north lines are parallel, this must be 20 because they add up to 180 degree. If I know that's 20, that's 130. Okay, so straight away, I know quite a lot of things, but also due south. Think about due south in angles. I actually gave it out just now in the question. See if you remember what I said. Due south means it's vertically below. Vertically below means that's a straight line. That means this is 180 degree. If there's 180 degree, this must be 20 degree. Okay, so straight away, you now have a lot of information that you can use to work out X. To work out X, what can we do in here? Now I got two angles, two lengths. So two lengths, two angles. We are thinking about sine rule. But if only sine rule, I need to find out this angle as well. But easy now, 130, 20, 150 from 180. This must be 30 degree. So sine rule. Okay, sine rule. So sine rule. So x over sine 130 degree equals to 70 over sine 30. So x equal to 70 over sine 30 times sine 130. Sine 130? Yep. So 70 over sine 30 times sine 130. Yep, 106 kilometers. Okay. So I think the difficult of this question comes from sketching a diagram. However, I'll give you actually you can be assured in the real exam you rarely have to draw these kind of questions. This is more just problem solving question, just to train up your problem solving skill. But in the real exam question, you rarely get a bearing question or that you have to draw something like this. Okay.